Hello everyone, welcome to my channel Let's Mathemagic. So today we are going to discuss about geometry, a very fundamental matters of geometry. We will start with a point which is zero dimensional and we will elevate it to the three-dimensional objects like the polyhedrons. So let's get started. So I'll begin this video with the legendary mathematician Leonhard Euler. He is famous for his two formulas. One is Euler's formula that connects the complex I with the trigonometrical functions, that is e to the power I pi plus 1 is equal to 0, and another one is the Euler's polyhedra formula, that is f plus v is equals to e plus 2. As you can see here that it is a triangular pyramid. So in this pyramid, if you count the number of vertices, that as I've taken the colorful magnetic balls, so here you'll find out there are total 4 balls are here. That means there are total vertices in a triangular pyramid. So if you count the number of sticks that I'm using here, so you'll find out it as 6. So the number of edges is 6 and the number of faces in a triangular pyramid that you'll find out is equals to 4. So here f is 4, v is 4 and e is 6. So if you put in the formula, you'll find out that 4 plus 4 is equal to 8 and 6 plus 2 that is also equal to 8. So the formula is verified.
So in geometry, this is considered as a point at what? The point is called zero dimensional. Now this is a point, so it doesn't have any length, any breadth, nor a height. So that is why it's called a zero dimension. Now we can consider it as a straight line. Why? Because I do not have connected any kinds of points either sides. So this is infinitely extended towards the right side as well as the left side. So this is a straight line and we cannot measure the length of it. Now what we can see, we can consider it as a ray. Because one side I can see there is a point and another side is infinitely extended. So this is a ray and ray is directional. And just like the straight line, we cannot measure the length of a ray because one side is infinitely extended. So we cannot find out a finite length of it. Now what we can see, this is an example of a line segment. And the line segment is finite. Why? Because in the either side we can find out there are point. So now we can find out a finite length of it. Now what we can see, this is a real number line. We can consider this point as the 0, which is a neutral integer, neither positive nor negative. And as we can see, then the right side there is no point, nor in the left side. So that means it is infinitely extended towards the right as well as in the left. So now in this real number line, we have all types of real number like integers, fraction, decimal, improper fraction, proper fraction, all types of rational and irrational numbers. Now what we can see, this can be considered as a plane because we have now considered two real number line perpendicular to each other, what in coordinate geometry we call axis. The horizontal one is called the x-axis and the vertical one is called the y-axis. And as we can see, none of these four sides having a point, so all of these four sides are infinitely extended. And when this all four sides will infinitely extend, it will create a plane. This can be represented as a space because the previous one that I've explained to you, the horizontal one is the x-axis, the vertical one is the y-axis, and as you can see there is another axis that I've added here that is perpendicular to this plane. So this is now creating a three-dimensional figure, whereas the new axis that I've added here that is perpendicular to the other two axes. You can check this angles, like this angle, this is 90 degree, the angle between these two are also 90 degree, and the angle this two is also 90 degree. So each of the angular pair, each of them are right angle to each other. So this is an example of a space. Now what we can see, that is a triangle. So what you can see here, this is an example of a triangle which is a polygon because all of the sides of this enclosed figure are one line segment. Now let us make one change here in this figure. Now though it is still a closed figure, but this won't be a polygon. The reason is why one side I have replaced with a curved line, so this cannot be a polygon. So a polygon should be a closed figure surrounded or bounded by line segments only. So this is not a polygon. Now the shape that you can see, this is a 3D shape. I hope all of you agree with me. Now this shape is called a pyramid. This is a triangular pyramid. Now all of you can check one thing here. A pyramid should have all the lateral surfaces as a triangle. Now the base can be a triangle or any other shapes. Now depending on the name of the base, the name of the pyramid is made. Like now suppose I change the base from a triangle to a square, the name will become the square pyramid. Let us make the change now. Now the shape that has been formed, this is a square pyramid. All of you please check, all the lateral surfaces are still a triangle. Now the base has been changed, now this is a square. So that is why the name of this pyramid is a square pyramid, because the base is a square. Now depending on the base, it can be a pentagon, hexagon, heptagon or septagon, monogon, decagon or any other shapes. So based on that, the name of the pyramid will be changed. Now the shape here you can see, this is a prism, this is a triangular prism. Now here in this prism, all of you can see one thing, these two faces, 1 and 2, these two are triangle. Apart from this, all are rectangles or can be square. So this is an example of a prism. Now this prism can be a square prism or a pentagonal prism depending on these two sides. If now these two sides is a square or a pentagon, hexagon, heptagon or any other things, now this prism can be called as a square prism or a pentagonal prism depending on the name of the shape.
If you find the video informative, please share it with your friends and follow me on my social handles that I've already given, and do not forget to visit our website for current updates. Thanks for watching. Jai Hind, Vande Mataram, and keep in touch with Let's Mathemagic.